Okay, now we will look at the example here where we need to identify forces based on a given situation. Okay, so we look at the first one. A box of mass m moves with a constant velocity v on a frictionless surface. Identify forces acting on the box. So we have a box here with a mass m, moves with a constant velocity v on a frictionless surface. Okay, so before we can identify the forces based on the keywords given here, so these are all the keywords. So it's easier for us to identify if we draw the situation here. So lukis dahulu. So we are given a box here. So this is a box, and this box moves with constant velocity, but we're not given the direction. Kita tidak dibagi direction, adakah dia to the right or to the left, but we can assume. So we can assume maybe the direction is to the right. So lukislah ke kanan, going to the right, and then symbol V. And then given here a frictionless surface. So meaning that this box is placed on a surface. So lukis surface dekat sini. And this surface is frictionless. So apa maksud frictionless dekat sini? Meaning that there is no friction. So no friction. So we don't have friction force. Although we know that the box is moving, but since it is frictionless, so no friction force. Okay. So now that we have the diagram here, we can identify forces. Okay, so first yang wajib sekali adalah weight force. So every object has a weight force, which is going downward. And then label W. And since the box is on a surface, means it has a normal force, which is perpendicular to the surface. So ni normal force, perpendicular 90 degree to the surface. Okay, what else do we have? Okay, nothing else. It's just we only have normal force and weight force sahaja. Okay, next one here. A box of mass m is pulled along a horizontal surface by a force Fp applied at an angle theta above the horizontal. Assume that the surface is rough. Identify forces acting on the box. Okay, so now we have box with mass m, and then the box is pulled along a horizontal surface by external force. So Fp, remember, external force, di mana it has an angle theta above the horizontal. And then we assume that the surface is rough. Okay, so first of all, let's lukis dahulu. We have a box. So this is the box. Okay, and this box is on a surface. So lukis surface. So this is the surface, and this surface is rough surface. So remember the keyword here, meaning that we have friction. Okay, kita akan ada friction. Okay, so now we have external force. Okay, kena lukislah external force ni. So external force ni adalah ada angle dia dekat sini. Angle dia above the horizontal. Dan external force ni adalah pull. Okay, dia adalah pull. Pulling force. It's not push. So kalau pull, okay, kalau pull kita boleh letak dekat sini lah. Maksudnya dia tarik daripada sini dan direction dia ke atas. So we can say here, this is the external force, and then at an angle. Okay, kita boleh kena label lah angle dia. So angle ni, so angle you need to use dotted line. So angle here, but we are not given the specific angle, so just label sebagai theta. And then since it is pull, so it's going towards here. Okay. And then next one, we know that every object has a weight force. So label W, and then since it is on a surface, so we have normal force. So normal force 90 degree to the surface. Okay, and then last one we have friction. So how we determine the direction of this friction? Okay, since pergerakan box ni sebab dia ditarik kan. Okay, dia ditarik ke arah ni kan. So friction ni, remember it must be opposite from the motion. So motion dia adalah ke sini. So bermaksud friction is going to the opposite side. So friction is going to the left. And what friction is this? Since it is pull, bermaksud dia bergerak lah kan. So meaning that the friction here is kinetic friction. Okay, friction, remember it must be on the surface. Sebab ni adalah surface, so friction must be on a surface. So that's all the forces that we have on this given situation. Okay, we look at the next one. So we are given a diagram here. Okay, so a box of mass MA rests on a rough surface inclined at theta, angle theta to the horizontal. So we have a box of MA, this one, which is at rest, and it is on a rough surface. So this surface here is a rough surface, and then it is connected by a lightweight cord. So this is a cord over massless and frictionless pulley. So this pulley is frictionless and massless. So meaning that this pulley is not considered as an object lah. Maksudnya this pulley doesn't have a friction force and weight force. And then it's connected to a second box, MB here, which hangs freely as shown below. The system is at rest. So apa maksud the system is at rest? Bermaksud kedua-dua box ni there is no motion. Okay, no motion for both of the box. So now identify all forces acting on MA and MB. Okay, so since we have two box, so bermaksud each box has its own forces. So setiap box ni kena identify dia punya forces. Okay, kita tengok yang first one dahulu, MA. So box MA dia adalah at rest. Okay, it's not moving, so it's just at rest. And then this one is on a rough surface. So kalau rough surface bermaksud akan ada friction force. Okay, so kita akan label yang paling penting dahulu, di mana setiap objek akan ada weight force going downward. And then since dia adalah dekat surface, so we'll have normal force, which is 90 degree. So make sure dia 90 degree. Normal force is 90 degree to the surface. Okay, and then this box is connected to a cord. So ada tali dekat sini. So kalau ada tali, remember mesti ada tension force. Then tension force must always away from the object. So objek dia dekat sini. So kalau away, maksudnya direction dia adalah ke sini. So this is the tension force. So label as TA. Okay, so now we want to identify the direction of the friction. Okay, first of all, since MA ni adalah at rest, dia tidak bergerak, so friction yang terlibat adalah static. Okay, Fs. So direction dia macam ni. Direction, remember dia adalah opposite. Okay, opposite daripada direction of motion. But since kita tiada motion dekat sini kan, so kita kena tengok macam mana untuk kita prevent box ni daripada bergerak, we want to prevent the motion. Okay, since there is tali kan dekat sini, maksudnya dia akan tertarik ke sini. So untuk dia prevent daripada motion, dia akan di opposite direction. So bermaksud static friction dia adalah opposite to this one. So maksudnya kalau dia ditarik kan, kalau dia start bergerak, the whole system, if it start moving, okay, this box will be going towards here. So friction force ni mesti prevent dia daripada moving or prevent the motion. That's why dia adalah opposite here. Okay, so that one is for the first box. And then second one here, MB. So this MB, first we have weight force. Always ada weight force going downwards. And this box doesn't have normal force sebab satu dia bukan dekat surface, just hangs freely. So dia ada tension force. Then tension force will always be opposite, okay, away from the object. Okay, anything else that we have? No, we only have weight and tension untuk box B. Dan untuk box A kita ada weight going downward, normal force 90 degree, and then since it is connected to a cord, it has tension force, and then since it is on a rough surface, dia ada static friction. Static sebab the box is at rest.